Hello students, today we are going to discuss about the sodium alginate, right? Since we are discussing about carbohydrate containing crude drugs, the 11 drugs we are supposed to discuss. So today the drug which is there, it is named sodium alginate, right? Actually this drug also obtained from marine source. It is the seaweeds which it is growing the brown algae inside the different types of different seas in different countries. From that we are going to extract the particular types of alginic acids that we are going to have the carbohydrate contain, right? So this drug also become important since it is obtained from marine organisms, right? So you can see into the image here how the brown algae it is looks like when it will be there. This kinds of plant which is growing inside the sea or ocean, that we are going to collect it, right? You can see how the in between the fishes also inside the sea or in the sea water, how this plant can grow very long, right? Because they don't need any support, and since water they are getting already support from the water, and they will be looking like this, then later on they'll become like brown. So that's what it is known as a brown algae. From there we are going to extract the alginic acid and further for carbohydrates, right? So different synonyms how the plants or the particular drug it is known as, you can see into the first synonyms, that is the algene, algine. From algene only it is also known as alginic acid sodium salt, since sodium salt will attach there, right? Then third synonym we can call sodium polymenuronate, right? Then fourth one kelgene, ke, right? Instead of a it will be ke, kelgene. Minus also it is known as, and protanol, right? So these are the different names where in different country it is known as. Biological source, so when we discuss about the biological source, we are supposed to discuss about that algae from where we are getting this particular drug. Sodium alginate is the sodium salt of alginic acid. Remember, you should remember this one, right? Sodium salt of alginic acid we are getting. Alginic acid is a polyuronic acid which is composed of reduced manuronic and glucuronic acids, right? Which is obtained from the algal growth of species, different species of the family Phaeophyceae. From this family, whatever the different species of algae it is there, or algal growth which is there, which is the combination of the manuronic and the glucuronic acid, right? From there we are getting the alginic acid that is going to have a drug content. The common species of from this family Phaeophyceae, the Macrocystis pyrifera, that is the one species. The another species Laminaria hyperborea. The third species Laminaria digitata, and Escophyllum nodosum, and also the Durileia lesonia. So these are the different species of algae that is belonging from the Phaeophyceae family. It is purified carbohydrate extracted from brown seaweed, that is the algae, brown seaweed. That's what we could see into the picture, right? It is the brown in color. You can see this is the brown seaweed or brown algae which is there in the plant, this many plants, by treatment of dilute alkali, right? So this purified carbohydrate we are getting from by the treatment of dilute alkali of seaweeds. When we talk about the geographical source, where is the source in the earth or country where this where the sea situated in that these particular plants can grow and the algal growth can be extracted out. Seaweeds are found in Atlantic and Pacific oceans, right? So Atlantic oceans also, we you know that it is there in India also, right? Then particularly in coastal area or coastal lines of Japan, United States, Canada, Australia, and Scotland, right? In India, it is found near the coast of Saurashtra, right? Saurashtra, Saurashtra. The largest production of algene is in United States and the United Kingdom, US and UK. So you can see here in the images, right, how this plant will grow without support very long, right, from the lengthy from the bottom, right, and they don't need support since they can have the water support, and from there we can get that brown algae or brown seaweed. How to collect? The collection and preparation, it is very important here because it can grow inside the ocean, right? The brown colored algae that we need to identify, how we can see into the image, are used for extraction of alginic acid, because since alginic acid only it is our target from that brown algae, right? The color is due to carotenoid pigment present in it, right? This brown color, since we are getting in carrot, how we are getting this pink color, right? Pink, red, right? Like that, because why? The carrot is very much famous for the having the carotenoids. So these carotenoids pigments, it will also be present in this brown algae, right? That M pyrifera, that's what we have discussed here. uh, the Macrocystis pyrifera, right? So this is the one species, the Macrocystis pyrifera, the principal source for global supply. This species, it is the main, we are getting it from alginic acid, is the perennial plant that lives from 8 to 12 years. The lifespan of this particular plant inside the sea, that is the what? 8 to 12 years, and grows as much as 30 centimeter per day. So it's a very good growth, we can say. You can imagine it 8 year and per day 30 centimeter means how long they can grow in a single plant. Since it is growing into the ocean or sea, that much surface area or that much area they are getting very easily. If they will grow in some lake or some other water reservoir, it is not possible, right? This gain, the kelp is found mainly in Pacific Ocean. That's what it grows on stands from 15 meter to 1.5 kilometer in width and several kilometer in length. In length we cannot imagine, right? Since 8 year is life minimum 8 year is the lifespan, and a 30 centimeter per day means it is several kilometer it is going. But width itself is 15 meter to 1.5 kilometer. Just imagine width 1.5 kilometer means from here to the Met, right? That much distance it is going to have. The mechanical harvesting is done about 4 times a year. Wherever it is collecting or harvesting has it is going on, that can be done 4 times in a year, since it is growing very fast. So immediately in another every 3 months you are going to get the again brown algae with that plant. So if you look after the processing, the alginic acid is present in this particular plant. The seaweeds are harvested, then dried like this, right? And the milled, how the drying will be done, you can see into the sun, direct sunlight with the different thread they are going to put, and the water content will go down and it will dry into the sun, and then milled and extracted with dilute sodium carbonate solution. This chemical we are going to add, which results pasty mass, right? When you will treat with this, you will get the pasty mass. It is then diluted a separate insoluble matter, right? To separate whatever the insoluble matters it is there in that it may be the sand particle, it may be the some other foreign matters, that can be diluted. Soft water is only used for extraction purpose, so as to avoid the incompatibilities, because so many other things, since it is obtained from the ocean inside, so many other unwanted thing will be there. That's what we are using the soft water. It is treated with calcium chloride or sulfuric acid. For what? For conversion into either calcium alginate or insoluble alginic acid, because ultimately our goal is to take or extract the alginic acid in different form, which is collected and purified through washing. Washing has to be done in several steps. If calcium is used, as you have seen here, the calcium chloride, right, it is treated with the hydrochloric acid. The alginic acid so collected is treated with the sodium carbonate for neutralization and converted into sodium salt. So depend on the treatment, it is going to have the particular salt is going to attach with that alginic acid. The alginic acid contained on dry solid basis varies from 22% to 35% in all the varieties of brown algae, right? So in any variety, if you take the solid basis, it is varies from the this either 22% or to up to 25, sorry 35%. So when you are getting that one, how the description is going to be? If you see the color, it is going to have the white to buff colored powder, because in that we are considering the purified carbohydrate, right? So the purified carbohydrate, after going to these steps, right, after so many treatment, after drying, milling and extracting and having the treatment with the different salt like calcium chloride or like sodium carbonate, it is going to have the white to buff colored powder, and it will not be having any odor, it is odorless. Taste also no taste, tasteless, since it is carbohydrate containing. If you see the appearance or outlooking, it is available either as a coarse or fine powder. It is readily soluble in water forming viscous colloidal solution and insoluble in alcohol, ether, chloroform and strong acids. 1% solution of gum at 20 degree centigrade temperature may have a viscosity in the range of 20 to 400 centipoises, right? So that we are know Ostwald viscometer, how we are measuring the viscosity. So in that much, in 20 degrees, that's what temperature is very important when it comes to the viscosity or the flow property of that particular gum. So 1% in 20 degree, it is having 20 to 400 centipoises. How you are going to identify that particular powder which is obtained from brown algae? The first identification test, it is precipitate formation with calcium chloride. So with this calcium chloride, how it is going to give the positive result when it is sodium alginate to a 0.5% solution of a sample in sodium hydroxide NaOH, add 1/5 of its volume of 2.5% solution of calcium chloride, right? So this, that's what our the test name itself is for PPT formation with calcium chloride. So a voluminous gelatinous precipitate is formed if you treat with calcium chloride. This gelatinous PPT you are going to form. This test distinguishes sodium alginate from gum arabic, sodium carboxymethyl cellulose, and carrageenan, gelatin, gum ghati, karaya gum, and tragacan gum, whatever the other example of carbohydrate containing crude drugs, that also will give this particular taste. Precipitate formation with aluminum chloride, aluminum sulfate, right? So aluminum sulfate to a 0.5% solution of sample in sodium hydroxide, again add 1/2, you have to remember this quantity, 1/2 of its volume. Whose volume? This volume, right, of the saturated solution of ammonium sulfate here, right? Here we have used the calcium chloride, here we are going to use the aluminum sulfate. No precipitate is formed, that is the indication, right? Here gelatinous precipitate is formed, here no precipitate is formed. This test distinguishes again sodium alginate from agar, sodium carboxymethyl cellulose, carrageenan, methyl cellulose, and starch also. The third identification test suggests that test for alginate, since alginate will be there, the moisten 1 to 5 mg of sample with water and add 1 ml of acid ferric sulfate. Within 5 minutes, a cherry red color develops that finally becomes deep purple. from red to purple. So that is the positive indication of the presence of alginate into the sample powder. Fourth test you can perform, that is the 1% solution in water forms heavy gelatinous precipitate with the dilute sulfuric acid H2SO4. Heavy gelatinous means concentrated one that you are going to get. That is the indication of the presence of sodium alginate. So let us discuss what are the chemical constants will be there in the given sample of powder. Algene consists chiefly of the sodium salt of alginic acid. Alginic acid, always you should remember, this is the main, the linear polymer of the gluuronic acid and the D-manuronic acid. The chain length is long and varies from the mole weight from 35,000 to 1.5 into 106 with the method of isolation and the source of algae. It depends. The manuronic acid is the major component. The alginic acid molecule appears to be the copolymer of 1,4 linked monoparenosyl uronic acid units of 1,4 linked the guloparanosyl uronic acid units and segments where these uronic acids alternate with the 1,4 linkage. That's what here we can see 1,4 linked, like manoparanosyl uronic acid and glucoparanosyl uronic acid, right? So like that, this linked the manuronic acid that you can have this one, right? Manuronic acid is the main example, and alginic acid that you can remember. Coming to the uses, what are the applications and uses of this particular drug? High and medium viscosity grade of sodium alginate. Sodium alginate is the main which we are discussing here, are used in the preparation of paste, creams, and for the thickening and stabilizing emulsions. So three formulation you can see: paste, cream, and emulsions. In the pharmaceutical aid, this is a very good pharmaceutical aid. That's what we have discussed in the scope of pharmacognosy. It is a good suspending and thickening agent. It suspending agent means it will be used in the suspension. Thickening agent means it will be used in the tablets. But a poor emulsifying agent. Emulsifying agent it is, but it is having poor property, right? It can be used, or if you are having any alternate, you can go for the good one. It is used as a binding and disintegrating agent in tablets and lozenges preparation. In food industry also, it is used for the preparation of jellies, different jellies, candies. It is available there also. It can be used. Ice cream, right? Ice cream stabilizer it is, etc. It is also used in textile industry. See, industrial exposure it is more pharmaceutical, food, and textile industries. For pharmaceutical purpose, when desired, it is stabilized by heating in an autoclave, right? It's sorry, sterilized by, because since it is obtained from the marine sources, so many microbes we can expect there, right? So that's what, if it is required for pharmaceutical purpose, it can be sterilized by autoclave. It is recommendable, right? You need not to go for the other alternate. Autoclave can be done with that much pressure and temperature. It can be sterilized. That's what we are discussing. You are discussing in microbiology, the moisture heat sterilization. That is the example. The solution of sodium alginate should not be stored in metal containers. That is the precaution. Metal containers we are not supposed, because metal can be corrosive since it will be having moisture content. That's what. It is preserved by the addition of 0.1% of chloroxylenol, then chlorosyrosol, benzoic acid, and parabens. This can be used for as a preservative. Potassium, aluminum, and calcium alginates are also used medicinally. These are also having these different salts are also having the medicinal importance. So you can see the capsule containing sodium alginate and the calcium carbonate are used to protect the inflamed areas near the entrance to the stomach, like duodenum, jejunum. It is there, no. So if inflammation occur in that area in digestive tract, these particular salts, that sodium alginates and calcium carbonate, can be used, and it is in the practice also. The acidity of the stomach cause formation of insoluble alginic acid and carbon dioxide. That's what we are getting gas from the our mouth route. Okay, the alginic acid rises to the top of the stomach contain and forms the protective layer, and it can be avoid the gas formation and the acid formation into the acidity that can be used. And because since it is uh, creating the protective layer onto the top of the stomach, right, so that will be helpful to release from this particular disorder, right. So since this drug, it is from obtained from the ocean and seaweeds, so we are getting to extract the alginic acid, so that drug becomes important since it is obtained from marine source, and it is very good source for the purified carbohydrate, and it can be cover for the carbohydrate containing crude drugs, right.